Hi, this is Mr. Guy, and I'm basically going to go through a absolute advantage and comparative advantage problem all the way to the end. I'm going to put it on the board. It's one that I'll be doing in class, plus I'll have others in class where we're actually going to go through figuring out what is absolute advantage, what is comparative advantage, finding the lowest opportunity cost, finding the terms of trade, drawing the production possibilities curve, showing the self-sufficiency point, and then showing where the trade would be after self-sufficiency, and then how both countries benefit from the trade, doing the comparative advantage and doing the trade. So we're going to be looking at the US and Japan, and I've got some numbers up here. So US is going to be making automobiles at 500,000. Japan is going to be making automobiles at 400,000. Wheat is the next product. US is going to be making 800,000 bushels of wheat, and Japan is going to be making 500,000 bushels of wheat. So the first question is, who has got the absolute advantage in automobiles? You look at who makes the most automobiles, and it's the US. Then you look at who has the absolute advantage in wheat. So you look to see who makes the most. 800,000 is greater than 500,000, so the US has an absolute advantage in wheat also. So, like I've said in the PowerPoints and notes, a country can have absolute advantage in two products, and it might look like, well, the US shouldn't trade, but countries do benefit from trade, even when they specialize and they do this. So we're going to try to find out what is going to make a trade better off. So the US, I created a production possibilities curve. Now, in these problems with comparative advantage and absolute advantage, we assume that the country can make both of the goods equally. So it's a constant opportunity cost, just because it's such a difficult concept to understand. It's a difficult one to do, and if you drew a bowed out production possibilities curve, it would be harder to show the benefits and the shifts and that kind of stuff. So we assume that the country and the companies can make both products equally well using the same resources, so it's linear. So 800,000 for wheat in 0 autos, or 500,000 autos and 0 wheat. And then typically for the point at self-sufficiency, we split it in half. So this is 400 autos and 250 wheat. And this point A is the self-sufficiency point. So when we do a trade, hopefully we're going to be outside the production possibilities curve, showing that this trade made the country better off. Japan, they can do 500,000 in wheat, 400,000 in auto. We just do the linear line. The point of self-sufficiency is 250 wheat and 200,000 autos. So these are the PPCs for each one. This is the absolute advantage, and the US has the absolute advantage in both products. Now, in comparative advantage, only one country can have the comparative advantage. They can't have a comparative advantage in both of them. So what we do, this is an output problem. So the output, the other goes over. So I put this out here. So 800,000 goes over 500,000. So it's 8 wheat. You just bring it all down, take away all the zeros. It's 8 wheat. So one automobile equals 8 wheat. And then one wheat equals 5/8 of an auto. And realize they're both reciprocals, they're inverse. So once you have 8 wheat, then the other is 5/8 auto, and it's automatically like that. Now with Japan, for one auto equals, you take the 500,000 over the 400,000, it's 5/4 wheat. Then you do the same thing, you take this and put it over, so this is 4/5 auto. Now these numbers are now your opportunity cost of one, so you're looking for the comparative advantage, the lower opportunity cost in each column. So we look down, this is automobiles, which number is lower? This one is lower. And then right here, this number is lower. So in this case, Japan should make autos and the United States should make wheat. So comparative advantage for autos is Japan. Comparative advantage for autos, for wheat is the US. So wheat is the US, automobiles is Japan. So we try to make this easy when we're doing a trade, that they're going to make everything that they're good at. So the United States is going to make all wheat and export wheat. So U.S. is going to do that. Japan is going to export auto. So the U.S. is going to make wheat and export it and then import autos. Japan is going to make autos, export the autos, and import wheat. So here we've got the absolute advantage, we've got the comparative advantage. Now we need to look at terms of trade. So to me, I look at this and it's one auto equals, so one auto will equal 1.5 wheat. The range can be anywhere between one auto equals 8/5 wheat or one auto equals 5/4 wheat. So it should be a number in between them. If it's the actual range there, one country will benefit, the other will stay the same. You'd like it in between. I always pick even numbers as best I can. I try to use 0.5, 0.25, or whatever it might be. So this is 1.25, this is 1.6, and I just basically did 1.5. So one automobile equals 1.5 wheat. So then we have to come up with a trade. So we know that the United States is going to be making 800,000 wheat. So they're going to be making 800,000 in wheat, 0 autos. So they're not going to make any autos. They're going to make all wheat, 800,000. Japan is going to make 400,000. Japan is going to make 400,000 autos and 0 wheat. And then they're going to trade. Now we have to have some kind of trade where we have to look at it, and the trade can't be the U.S. is trading like 1 million bushels of wheat because they don't have that. They only have 800,000 wheat. Japan can't trade more than 400,000 autos, and they want to keep some for themselves. So we want a number in between something that we have. So I basically did this, and I came up with we're going to trade 200,000 autos. So we are going to trade 200,000 autos for 300,000 wheat. So one car equals 1.5 wheat. It's the same ratio. So 200,000 autos for 300,000 wheat. And that's within the ranges. Japan can make 200,000. They have enough. They have some left over. The United States with a 300,000. So that's what we're going to be doing. We're going to be doing this trade. So we're now going to take minus 300,000 wheat. So U.S. makes 800,000 in wheat. They subtract 300,000 in their trade, so they're left with 500,000 in wheat. But the big but is they get 200,000 automobiles. So the United States is going to end up in this trade with 200,000 autos, and they're going to end up with 500,000 wheat. Japan is going to end up with 200,000 autos after the trade, but they're going to get 300,000 wheat. So that's what they're left over, and then basically I plot this on the production possibilities curve. So I'm going to plot for the United States 200,000 autos, 500,000 wheat. So here's 200,000 autos, 500,000 wheat. So that's point B, that's outside the graph, that's outside the line. The United States is better off than self-sufficiency. 200,000, 300,000. Japan is going to have 200,000 autos, 300,000 wheat. Japan is outside the line, and they're better off. This trade makes both countries better off, even though the United States has an absolute advantage in both products. So just to recap here, the United States has the absolute advantage in autos and absolute advantage in wheat because the numbers are higher. So the numbers are higher. Then we look at who has got the comparative advantage. So we look at here. Japan has the comparative advantage in autos because 5/4 is less than 8/5. United States has the comparative advantage in wheat because 5/8 is less than 4/5. So we're looking at that down the range. This is the product, and we're looking to see who has got the lower opportunity cost. They are going to export what they have the lower opportunity cost, and they're going to import the other product. And then basically this is the production possibilities curves. So you just plot the 2 points, 500,000, 800,000, 400,000, 500,000. You plot those on the graph first. You divide the number in two so you can get the self-sufficiency point. So you just split them up and then you do the trade. Now the trade and the terms of trade have to be one auto is somewhere in between this. You could also do, if you wanted to, one wheat. So one wheat would be between 5/8 auto and 4/5 auto, so some fraction in between there. Either one works, either one's fine. You just need it to be in between the number, not at the margins or not outside the margin. So I always say the terms of trade is a range. You want something in the middle. If you've got whole numbers, that's easier. If you've got halves and quarters, that's also easier. And then you plot it out. Now, I'm not using graph paper. You guys are probably not using graph paper, so sometimes we have to look and see, is it outside or is it right on the line, because you have to kind of like make these very simple numbers and do this. And a lot of times we're using fractions that sometimes don't make sense. I'll try to always have fractions that are 3/4, 1/2, but it's not always possible because a lot of you will have questions. I'll make up a problem and then we'll put it out there. So hopefully this helps. There's other videos that I posted from other teachers. You have the PowerPoint in class, and we'll be going through this problem quite a bit. If you have any questions, make sure to post in classroom, post beneath this video, and see you in class. Thanks a lot.